Hi everyone, myself Divya M, first MSc Microbiology, Sacred Arts College, Tirupattur. This present video is about flame photometer. We will see in this video who discovered this flame photometer, how it's working, where this instrument is used and what is the advantage and disadvantage of this flame photometer. Now we will see the introduction. Now flame photometer. The flame photometer is developed in 1980 by Bowling Burness, David Richardson, John Berry, and Robert Hood. This instrument used to measure the low concentration of sodium and potassium in a solution. In the flame photometer is based on the measurement of the emitted light intensity when a metal is introduced into the flame. The wavelength of the color gives information about the element, and the color of the gives information about the amount of the elements present in the sample. The flame photometer is the one of the branches of atomic absorption spectroscopy. It is also known as flame emission spectroscopy, becomes a necessary tool in the field of analytical chemistry. This flame photometer can be used to determine the concentration of certain metals ions like sodium, potassium, lithium, calcium, and cesium, etc. In flame photometer spectra, the metal ions are used in the form of atoms. Next, we will see the principle of flame photometer. The compound of alkali and alkaline earth metal dissociate into the atoms when introduced into the flame. Some of these atoms further get excited to even higher levels, but these atoms are not stable at higher levels. In certain metal ions emitted the wavelength and colors in the flame photometer. The sodium emitted the wavelength in 589 nanometer in yellow in color. Potassium emitted the wavelength in 766 nanometer in violet color. Barium emitted the wavelength in 554 nanometer in lime green color. The calcium emitted the wavelength in 622 nanometer in orange color. Lithium emitted the wavelength in 670 nanometer in red in color. These atoms emit radiations when returning back to the ground state. This radiation generally lie in the visible region of the spectrum. Each of the alkali and alkaline earth metals has specific wavelength. The intensity of the emission is directly to the number of atoms returning to the ground state, and the light emitted is turned to the concentration of the sample. Next, we will see the part of the flame photometer. This is the instrument of flame photometer. Now we will see the how the parts is working. The source of flame. The source of flame is the burner in the flame photometer. It can be maintained in constant temperature. The temperature of the flame is one of the critical factor in flame photometer. Next, nebulizer. Nebulizer is used to send homogeneous solution into the flame at a balanced rate. Next, optical system. The optical system is consists of convex mirror and convex lens. The convex mirror transmits the light emitted from the atoms. Convex mirror also help to focus the emission to the lens. The lens help to focus the light on a point or slit. Next, simple color filter. The reflection from the mirror pass through the slit and reach the filter. These filters will isolate the wavelength to be measured from the top irrelevant emission. Photodetector. The intensity of radiation emitted by the flame is measured by photodetector. The emitted radiation is converted to an electrical signal with the help of photodetector. These electrical signals are directly proportional to the intensity of light. Next, we will see the working procedure of flame photometer. In this working procedure, we will see how the flame photometer is working and how the sample emitted the wavelength and color. Now we will see the procedure. First, we will prepare the stock solution and sample solution in fresh distilled water. Next, the photometer is calibrated by adjusting the air and gas. Allow to stabilize for about 5 minutes. Then the instrument is switched on and the lid of the filter chamber are open to insert color filters. Then the reading of galvanometer are adjust to 0 by spraying distilled water into the flame. Next, the sensitivity is adjusted by spraying the most concentrated standard working solution into the flame. The full scale deflection of the galvanometer is recorded. Again, the distilled water is sprayed into the flame in constant readings of galvanometer. Then the galvanometer is adjusted to 0. Now, the standard working solution is sprayed into the flame for 3 times and the reading of galvanometer are recorded. After each spray, the apparatus must be washed thoroughly. Finally, the sample solution is sprayed in the flame for 3 times and reading of galvanometer are recorded. After each spray, the apparatus must be thoroughly washed. Next, calculate the galvanometer reading. This reading plotted the graph of concentration against the galvanometer reading to find out the concentration of the element in the sample. Flame photometer are mainly air, oxygen or nitrous oxide. The temperature of the flame depends on the ratio of fuel and oxidant. Next, we will see how process occurring during flame photometer analysis. First, dissolution. Dissolution involves drying a sample in a solution. The metal particles in the solvent are dehydrated by the flame and the solvent is evaporated. Next, vaporization. The metal particles in the sample are also dehydrated. This also led to the evaporation of the solvent. Next, atomization is the separation of the all atoms in a chemical substance. The metal ions in the sample are reduced to metal atoms by the flame. Next, excitation. The electrostatic force of attraction between the electrons and nucleus of the atom help them to absorb a particular amount of energy. The atoms jump to higher energy state when excited. Last, emission. The higher energy state is unstable. The atoms jump back to the ground state or low energy state to gain stability. This jumping of atoms emit radiation with characteristic wavelength. The radiation is measured by the photodetector. Next, we will see how to calculate the wavelength of intensity light emitted with the help of following formula. This formula described by Shaibi-Lomenkin. This formula is I is equal to K into C power n. I is intensity of emitted light, C is concentration of the element, K is proportionality constant. The intensity of emitted light is directly related to the concentration of the sample. Next, we will see the applications of flame photometer. This flame photometer can be applied both quantitative and qualitative analysis of elements. The flame photometer can detect the presence of any specific element in the given sample. Next, this presence of sample in critical from soil health. This is present in soil sample by conducting flame test and the soil can be supplied with the specific fertilizer. Next, we will apply to identify the concentration of the sodium and potassium ions. Then the flame photometer is applying the soft drinks, fruit juice and alcoholic beverages can also be analyzed. The photometer to determine the concentration of various metal and elements. Next, we will see the advantages of flame photometer. The method is analysis is very simple and economical. It is quick, convenient, selective and sensitive analysis. It is both qualitative and quantitative in nature. Even very low concentration metal in the sample can be determined. This method also used to unexpected interfering materials present in the sample solution, also used to estimate the elements which are rarely analyzed. Next, we will see the disadvantages of flame photometer. The accurate concentration of the metal ion in the solution cannot be measured, cannot directly determine the presence of inert gases. This technique, total metal content present in the sample, does not provide the information about the molecular of the metals present in the sample. Only liquid samples may be used. The sample preparation becomes lengthy in some cases. This flame photometer cannot be used for the direct determination of the metal atom, cannot be analyzed by this method. This elements such as carbon, hydrogen and halides cannot be detected due to their non radiating nature. Thank you.